Okay. Hello, everybody. We are going to start. I'm Sébastien Deleuze. I'm working at Broadcom as a Spring Framework core committer. I have been working in the Spring Framework team for 13 years. I have recently joined the Spring AI team, so nowadays I split my time between Spring Framework, Spring AI. And today we are going to talk about how to build idiomatic Kotlin application with Spring Boot 4. So what are the guidelines, tips and tricks, best practices that you can apply. And yeah, that's a good time because Spring Boot 4 has been released recently, and I have a few new things to share with you today. But let's think about, does idiomatic code still matters in the age of coding agents? I think it does. If you don't care enough, you will see the entropy of your project increasing. The maintenance will be more and more an issue. You may observe performance, consistency issues. So if you vibe code your project, it may work the first few weeks, but after some time, I have seen already multiple examples of teams losing control over their project. And so I still think it matters to have a nice idiomatic code base. Also, GenAI tools tend to copy patterns from your existing code base. So if you have a crappy code base, it will just create crappy code. So having a nice and idiomatic code base will help also GenAI tools to generate good code. And also, you can turn these best practices into agent skills. So you can take some advice I share here, create some skills that you will put in your dot cursor or similar directories. And so it will be basically rules that your GenAI tooling will be able to reuse for your code. So let's talk about build systems. The current default for Spring Boot Kotlin project is Gradle Kotlin DSL. You can generate some related build system code with Spring Initializer. And so it will generate this kind of build.gradle.kts, providing Spring Boot plugin, dependency management plugin that allow you to override the dependency of one specific dependency that Spring Boot is managing. We recommend using Java 25 by default. Spring Boot 4 is still compatible with Java 17, but this is a minimal baseline. And nowadays, unless you have big constraints, we really advise you to use the latest Java LTS, which is Java 25. Some next generation declarative build tools are coming because it's cool to be able to write builds in Kotlin, but with GenAI and other constraints, it's even better to be able to have declarative builds. And so you may have seen that Kotlin toolchain, previously called Amper, is basically now supported, but more for simple projects. So I would not advise to use it, at least nowadays, for your Spring Boot project. For the middle long term, I really believe in declarative Gradle, which is basically a variant of Gradle. So after the Groovy DSL, the Kotlin DSL, there is now a declarative version, which is a bit close to the Kotlin syntax, but will allow to basically go faster, have better autocomplete, and various other benefits in your IDE. It's not yet ready for consumption, so today just use the Gradle Kotlin DSL, but in the future, declarative Gradle may be an interesting thing to explore when it will be a bit more advanced. Right now, it's available as a preview, and it's not really usable yet. We have been releasing a few months ago Spring Boot 4, which is the new generation. It brings many new features. We have been publishing this Road to GA blog post that summarizes basically the biggest feature. So the core resilience feature like retry, etc., API versioning in Spring MVC and WebFlux, HTTP client enhancement, etc., etc. A very important one, if you need to have a look to one single new feature, it is modularizing Spring Boot. Like Spring Boot has evolved, and instead of providing one monolithic auto-configuration module, it now provides multiple Spring Boot modules that allow to have more a stronger trigger to trigger a dependency, to trigger a feature. So instead of just relying on the class path, you will be able to have more stronger triggers. And I think that's really a game changer for finding the right balance between this feature is going to automatically be enabled magically and getting more control on what you ship. We are evolving the baseline. So the baseline for Spring Boot 4 is Kotlin 2.2. The benefits, I guess you already know, but faster compilation, better code analysis, Java interoperability, multi-platform, and also some language evolution that will allow Kotlin to evolve faster. So the minimal version is 2.2, but the recommended version depends on the version of Spring Boot. So for Spring Boot 4.0, we recommend using Kotlin 2.2. Spring Boot 4.1 that will be released in a few days, Kotlin 2.3 by default, and Spring Boot 4.2 that we will be releasing in November this year will likely leverage Kotlin 2.4 by default. Something very important, not everybody is aware, so I'm sharing, it's very, very important. You should upgrade to Spring Boot 4 not only for the features, but also for the support. I mean, we provide open source support for a certain amount of time, and in a few days, basically that will be the end of the support of Spring Boot 3.5. So you have two choices, basically either getting commercial support or just upgrading to Spring Boot 4 and just benefits to the open source support, CV fixes, etc. So that's pretty important. And if you have any kind of public website, I would not advise to have like unsupported version because you don't benefit from the security fixes, etc. And that's pretty important. So yeah, upgrade to Spring Boot 4. It's very important. An evolution of the Kotlin language to be a better fit with the Java ecosystem is the new annotation default targets. Usually, when you are building your Kotlin code, you are using Hibernate Validator, Jackson Annotation, basically annotation-based libraries that are coming from the Java world. You naively annotate your data class properties like that, and then nothing happens. Because basically, when you see the generated code from a Java perspective, it is just annotating the constructor parameter, not the field, not the property, and then it is invisible from Hibernate Validator or Jackson. And everybody does that mistake. It's not very good default. And so until now, the basically recommendation was to specify the annotation use side target by saying, OK, I want to apply this annotation on the field, but it's not very discoverable for newcomers, and we usually forget to do that, so that's not a good default. So we have been discussing with the Kotlin team, and the Kotlin team has proposed a nice solution, which is basically a way to change the defaults. So in Kotlin 2.2, it requires this -x annotation default target equals param property. Kotlin compiler additional arguments. And when you do that, basically, it will apply the annotation to both the field and the constructor parameter. So basically, the various ways where it can translate. And with that, by default, Hibernate Validator, Jackson will be happy. And the good news is that with Kotlin 2.4, this is the default. So now, as of Kotlin 2.4, you have nothing to do. Just upgrade to the latest Kotlin 2.4 version, when that will be a final, and then you will just be able to use @email or whatever Jackson, Hibernate Validator, other annotation. It will work out of the box. So that's pretty cool to see the Kotlin team solving this kind of Java interoperability issue, where basically there was no really good solution out of the box. So pretty cool. One of the biggest features in the Spring Boot 4 release is taking advantage of Spring null-safe APIs. In Spring Boot 3, we already had some null-safety annotation, but the support was very partial. We had null-safety annotation in Spring Framework and Spring Data, not other projects from the Spring portfolio. It was setting package default to non-null, like on Kotlin, and providing method and field-level null-safety, but there was a lot of limitation. We were not necessarily checking everything with build plugins, so basically, we had to rely on the community, basically raising issues and saying, oh, I can't use this method in Kotlin because you have a null-safety mismatch. You needed to specify to the Kotlin compiler that you need to translate to Kotlin null-safety. So we were doing that by default, but still that's a configuration that you had to apply to your Spring Boot project. There was no proper specification or canonical dependency. It was not usable outside of Spring, and the generic type nullability was not supported. So basically, for generic types, you still add those platform types, exclamation mark. With Spring Boot 4, we have done a lot of work. And when I say we, it's the whole Spring team. So I thank all my colleagues who did a lot of work to basically add consistently JSpecify annotation to all Spring projects. So basically, nowadays, all Spring projects, framework, data, boot, security, AI, etc., they all provide basically full null-safety for basically all their public APIs. And when you are using those projects from a Kotlin point of view, it feels like if it was Kotlin native API with full null-safety specified. We are checking everything with null away, so we are just not throwing annotation and basically hoping that we are right. We are checking the consistency of all null-safety annotation with a build plugin which is called null away. And basically, when we do a mistake, our build is broken and we need to fix that. So we are checking everything ahead of time to avoid any major issue on your side. It translates automatically to Kotlin null-safety as of Kotlin 2.1. So basically, there is no Kotlin compiler special argument. As of Kotlin 2.1, Kotlin compiler natively interprets JSpecify as Kotlin null-safety. And so you are fine. JSpecify is usable outside of Spring. So we see projects like JUnit and other one also leveraging JSpecify. And it deals with generic type nullability. So that's a big progress. So with Spring Boot 3, basically, you add this exclamation mark platform type saying basically, from a Kotlin point of view, I don't know if that's nullable or non-null. And so, yeah, basically, that was not preventing any kind of null pointer exception, and that was just disabling null safety checks for the purpose of getting something easy enough to use. In Spring Boot 4, before, after, we remove the platform types, and basically we have explicit nullability. That means when nothing is specified, the return value or the parameter is non-null. And if there is an exclamation mark, that means that it is nullable. And again, this is applied on the whole Spring portfolio, so the scope is pretty wide. So in practice, what did we do? We went to across all the Spring APIs on all portfolio projects. We added this @null-marked annotation at package level, which says basically the code within this package will be explicitly marked with @nullable if something is nullable, otherwise it's non-null. So basically consistent with the Spring defaults. When we specify nothing in the code base of those null-marked packages, that means this application context parameter of this application startup return value are non-null. And we specify explicitly nullable return values or parameter with this @nullable, and that automatically translates to the corresponding Kotlin null safety. So we did that on Spring side. If in your company you have Java libraries, for example, that you are using from Kotlin project, you can do the same. And even if you don't, if you just have Java workloads, you can also just add JSpecify, use null away to check the nullability also on your Java workloads. And so in practice, if you want to make your Java libraries null-safe, I advise you to read the JSpecify user guide, because really it's important to understand the semantics. JSpecify is for annotation, but it took 7 years to go to 1.0. So believe me, it's not just about getting agreement about the name of those four annotations. It's about defining the semantics, writing the specification that allow tooling vendors to provide a consistent behavior, and providing the user guide that allow you folks to basically understand the semantics. And when it comes to generic types, there is a few nuances that you need to understand. By the way, the specification and user guide from JSpecify are also useful for your GenAI coding agent, because that will help your agent to understand the semantics. So after reading the user guide, you should add the JSpecify dependency, annotate your packages with null-marked, annotate with @nullable, fields, method parameter, method return values. And I highly recommend you, it's optional, but I really recommend you to introduce build time checks with null away, because otherwise it really does not check the consistency of that. In my Spring I/O talk that is dedicated to JSpecify and nullability, I have explained how you can use GenAI coding agent to automatically add null safety to Java project. It was not possible a few months ago, but basically by pointing your GenAI agent to basically JSpecify user guide, pointing to the commits I did on Spring Framework and on other projects, basically you can say, learn how to add nullability to your project based on what the Spring team did, and basically do the same on my project. It's a simplified version, but it really works. And those last months, we were able to add JSpecify annotation for the remaining part of the Spring portfolio, just using GenAI tooling, using the right model. So it works, like for real, with the right prompt. Now, I have tried to provide answer to popular question I get like every day. It's my advice, but yeah, WebMVC or WebFlux. We provide two stacks. The traditional blocking WebMVC stack, where you're typically using GPA, JDBC, etc., and the WebFlux stack that is typically consumed with coroutines API in Spring World. And so we usually get these questions. I think nowadays, I would recommend WebMVC by default. I mean, WebMVC has always been the leader, like in terms of market share. Basically, WebMVC is between 80–90% always, and has always been, and that was the plan. Just WebFlux is providing a more reactive, scalable, streaming-oriented way to dealing with stuff. But very few people maybe realize, but WebMVC has support for coroutines out of the box. So you can totally use coroutines, return Kotlin flow within Spring MVC. It will just adapt to Spring MVC async support. It's a good idea to use it with Java 25 and virtual thread enabled. So with Spring Boot 4, you still need to enable it explicitly with this spring.thread.virtual.enable equals true. And it works perfectly fine. So I think by default, you should just use WebMVC. If you have specific needs, you can totally use WebFlux web client with WebMVC server if you want. Or basically, you can use WebFlux if you are really doing streaming-oriented and basically a workload that really take advantage of the coroutines reactive stack. But otherwise, WebMVC is really the default. By the way, in the upcoming month, for Spring Framework 7.1, we are working on making basically WebMVC leveraging even more virtual threads, structure concurrency, and basically providing streaming capabilities that are not yet available on the non-reactive stack. So really our goal is to modernize and basically make WebMVC even more first class for virtual thread, and basically with this infrastructure based on virtual thread, adapt to Kotlin Flow, Flux, or other things if you need. So that's an ongoing work that we are going to do. Now, programmatic or annotation-based configuration. You may be aware that I have introduced an experimental project called Spring Foo a few years ago that was experimenting basically how we can configure Spring with DSLs. Nowadays, this project is retired because we have basically leveraged a few outcomes of that project in Spring Boot, and we are going to do even more in the future. So in Kotlin, both are idiomatic. Myself, I tend to advise and prefer using programmatic configuration with DSL for smaller projects, microservices, and basically I use more annotation and discovery of basically the various bins for bigger projects. You can, of course, combine both, so it's not about choosing, but this is basically what I tend to do. If you are using annotations, I advise to use automatic auto-wiring of the constructor parameter. So if you have a single constructor, you don't have to specify automatically the @auto-wired annotation. It will be auto-wired by default. So here, you will have an auto-wiring by type of the repository parameter, and that's it, nothing more to do. You can combine admin and router DSL. That is pretty popular on Kotlin side. So basically, by doing this kind of thing, you can have your regular add configuration classes, and within that, using the Kotlin DSL for declaring web endpoints, and both will work perfectly. You can leverage the new bin registrar DSL capability in order to declare functionally some beans. So here, for example, I'm declaring a pet management bean. I'm declaring some router, etc., with the new version of this DSL, which is an evolution of the previous one. And the big difference is that this is pretty similar to what we were doing before, but the new feature is that you can very easily integrate that in your regular Spring Boot application or configuration with this @import beans class. Before, there was a bit two worlds. Either you are using @configuration or this Spring Full-I construct, where basically you are providing everything, defining beans with a Kotlin DSL. Nowadays, you will basically use bean registrar DSL to declare your beans, and you can integrate it in your application with @imports. And basically, you can combine both worlds, providing @configuration or this functional construct. It worked very well, and it's now compatible with Spring AOT, GraalVM support, etc. So it's really more first class, and we are going to continue to evolve these bean registrar capabilities in future versions of Spring. By the way, when you are using those DSL for declaring beans everywhere, you don't have to use Spring Boot application annotation that is going to do component scanning. You can just use @enable auto configuration and @Spring Boot configuration, and there will be no scanning at startup. So you can do this kind of optimization. Then, yeah, you can use the regular web router DSL to declare your endpoints, specifying the path, the content type, etc. Again, everything is possible. But the biggest feature of this bean registrar thing is not necessarily just declaring beans with a slightly better Kotlin DSL than the Java capabilities. It's creating your own configuration DSL. Basically, the reason why I push bean registrar DSL infrastructure is to allow you to provide your custom API to configure your application. Like, typically in Spring World, we are usually using @configuration @bean. But for more complex use case, think about Spring Security, for example. Spring Security is providing a DSL to configure Spring Security because with Annotation, you can't provide all the nuances, etc. And you can do the same for your library, for your context. And so you can provide your own custom, highly configurable DSL. By extending bean registrar, like I do in this custom DSL, you can basically provide your own types API, like this user types function. Okay, you can use any kind of signature. You are in control. In the implementation of those basically functions that are providing user-friendly API, you are going to do some registry.register bean with for loops, if statement, whatever custom logic you want. And then your user will have basically a custom DSL, which is not exposing low-level concepts like beans and stuff like that, just providing a kind of high-level API to configure your library. And I think that's something that you could easily import with this @import thing. And it's a very powerful way to configure your application with much more flexibility than @bean, because you can, again, do if statement, for loops, and you can hide the complexity to just expose what is needed for your end users. So in my opinion, much more than a Kotlin DSL that is slightly better to declare beans. The real superpower of that mechanism is really allowing you, the community, to build some custom APIs to configure Spring, and potentially some Spring project like Spring Security and others will leverage this mechanism in the future, but to be seen and discussed. Logging. Surprisingly, there is not an official, super simple way to do logging in Kotlin. So I have seen like dozens of small logging wrappers that try to provide something. So of course, I want to provide my own variant. So really, from my perspective in Spring, we are usually using SLF4j for logging. And so we just missed teeny wrappers to allow basically a nice integration in Spring projects. So the one I usually add in my project are those ones, basically. Logger for type, where you will basically explicitly specify the type with the verified type parameter. The logger that is going to do automatically detection of the current class, and basically some basically inline debug error, etc. wrappers. And so when you want to use them, you have the choice to either do this logger with automatic detection of the class. So here it will be a logger for user controller without having to specify it. If you don't like companion object like I do, you can basically put it outside of your class and use this logger for type variant that will create the logger. And that will work pretty well. In theory, an upcoming related official dependency will be included. Basically, we are collaborating with the Kotlin team to have this kind of basically tiny wrappers in something that is basically not just one additional GitHub repository with 10 star. So basically, the goal is to for the Kotlin community to have that as a kind of official library. It's not yet available, but potentially in the upcoming weeks or months that will be available, so just follow the news. For now, you can just copy that in your project if you think that's interesting and just use it. But it should be available in a library shortly. Testing. So two important things with this kind of test classes. The first one is that you can also, and you should probably, auto-wire basically this kind of property in order to just have val properties like that. Unlike with regular Spring components here, you need to explicitly use @auto-wired at constructor or parameter level. But then you can just do that, and I think that's a pretty good practice. I think in the next version of Spring Boot should be 4.1. Basically, constructor level Mockito injection will be also available. So you can use consistently this kind of pattern to inject mocks as well. Not in 4.0, but I think as of 4.1, Sam Brennan has been working on that, so that should be available if I'm right. The other thing is to try to use the Kotlin extensions that are providing a nicer syntax. And the IntelliJ AD team has done a pretty good work providing automatic fix for this kind of thing. So if you are using basically the Java version that is not idiomatic, you will have IntelliJ AD that will propose that by default. If you want to do that at scale on the whole code base, I would just advise you to use GenAI tooling and say, okay, check the CADOC documentation of Spring Framework, another project, identify all the Kotlin annotation, and apply the annotation on that code base. And I think within a few minutes, you will have your GenAI tool easily finding where you are not using them. And I think it's a good way to apply that at scale on projects. So, and your code base will be more readable, etc. Kotlin Serialization got a lot of love in Spring Boot 4. And I'm pretty happy about that because I think I got like various bugs due to inconsistencies and things that was not super clear. So I think it was due to some stuff that we needed to clarify on both Kotlin and Spring side. So basically, like usually, we have some regular meeting between the JetBrains team and the Spring team, and we have been discussing on how to solve that. And so in Spring Boot 3, there was no dedicated starter or module for Kotlin Serialization. The activation was a bit annoying because basically as soon as you had Kotlin Serialization in the class path, you had Kotlin Serialization support on Spring side that was enabled. And a few years ago, that was not an issue, but nowadays you have a lot of libraries that you just add on the class path that are using transitively Kotlin Serialization. And so it was a 2-week activation condition, and that triggered some issue. And the biggest issue is that there was some overlap with Jackson. So for basically, in theory, Kotlin Serialization only care about Kotlin classes annotated with @serializable, but in practice, its scope is wider. And so there was basically an overlap where basically Jackson and Kotlin Serialization were taking care about the same classes, and it was not a good thing. So in Spring Boot 4, we have tried to solve all those issues. So thanks to Spring Boot 4 modularization, you now have a dedicated Spring Boot Kotlin Serialization JSON module and related starter. It will only serialize by default Kotlin classes annotated with @serializable. So if you have enums or other types that were like in between Jackson and Kotlin Serialization, it's not the case anymore. only serializable by default, and you can customize it if you want more. No overlap with Jackson, and we have open polyformism support. So we have tried to fix all those issues, and since we have fixed that, we don't have any new open issues and people confused about the Kotlin Serialization support. So it looks like it's working as expected. Data access for SQL databases. So yeah. We had discussion with GPA expert, Kotlin teams, Spring Data teams, etc. At the end of the day, we need to accept, even if that's a bit painful, that idiomatic GPA is by design not compatible with idiomatic Kotlin. And so if you are using GPA with Kotlin, that's fine. But then accept to basically use var instead of var and use nullable properties, etc. Because GPA by design is designed for basically mutable properties, and you can try to fight it, but it will bite you. So I think, yeah, you need to accept. I know it's frustrating. I know it's hard. And if you are not convinced, or if you are convinced, the JetBrains team has done an amazing job documenting why this is not basically possible by design. And so you can have a look to those two very interesting blog posts written by, with inputs from Spring team, GPA experts, Kotlin team, etc. And basically how to avoid common pitfalls with GPA and Kotlin and using Spring Data with Kotlin. A lot of good insights, all the explanation to why it's not a good idea to have immutable properties, etc. And so, yeah, check the detail. It's the reference documentation on why you should basically follow GPA guidelines, which will not lead to Kotlin idiomatic code. If you want idiomatic code, you can use Spring Data JDBC exposed. I guess even with Juke, you should be able to have that. So it's not a lost battle, but again, you need to choose. Either you use GPA, or you use another persistent solution, and you will have nicer Kotlin code. So yeah, choose. Context propagation with coroutines, this is another area where we got a lot of issues. It took a lot of time to solve that, so sorry and thanks for your patience. And as of Spring Boot 4, we now have automatic context propagation with coroutines. That means your observability tracing will work by default when you are using Spring. Not totally by default because you need to configure the Spring Reactor context propagation equals auto because coroutines are built on top, basically the Reactor infrastructure. But you just have to add the context propagation micrometer dependency, configure this flag to auto, and then basically the coroutine context will be propagated automatically in the right way, and basically tracing and various things will work out of the box. If you want to have more advanced use case, you can have a look to propagation context element, which is basically the low-level class that we are using to implement that, and you can customize it or whatever. But I think that's pretty cool that it now works by default. We have an ongoing collaboration between the Kotlin and the Micrometer team to finish to fix the remaining Kotlin Micrometer issues. So we have ongoing active work, collaboration between both teams, and yeah, we are going to fix the remaining issues or provide the related enhancements. Spring AI. So, like I said, I have recently joined Spring AI, and these days I'm spending a lot of time in Spring AI because there is a lot of things to do. There is some guide to use Spring AI with Kotlin. We are going to update it in collaboration with the Kotlin team with Spring AI 2.0 that will be released shortly. And speaking about the roadmap, so the stable version is currently Spring AI 1.1, usable with Spring Boot 3.5. In a few days, it will be in early June, I should update this date. We will release 2.0. We had a big focus on Spring Boot 4 baseline, idiomatic Kotlin null-safe APIs, so basically the whole API is annotated with JSpecify, and focus on quality and consistency. So basically, Spring AI is a project that grew super fast, and we wanted to basically focus on a bit less models, but with better quality, testability, consistency, etc. So we have been doing a lot of work on basically increasing very significantly the quality, the performance, the consistency in terms of API, etc. And this is the big focus we had on 2.0. some modules that are not supported in the core project, they are now living on community side, and basically we are working with the community on that. 2.1 in November 2026 will have a focus on providing a new agentic API module, which will be called something like Spring AI Agent. And so that will be like an additional module that will provide dedicated agentic annotation and APIs. It's already possible to build agentic application with Spring AI, but basically you need to wire stuff manually with your code. Here we will provide more high-level building blocks to build basically agentic workflow or custom workflow with basically sub-agents, etc. So it will be a bit more high-level. And a new Spring AI session module that will basically replace the current memory support that is a bit limited, and basically that will provide short, long-term memory support with nice abstraction, and basically that will be the two big features that we will provide in 2.1 in November. And next year, we have a plan to provide virtual thread-based unified stack. So currently you have a bit the blocking and the reactive world, and we are going to basically pioneer a unified virtual thread-friendly stack with adaptation to Kotlin Flow or the API you want to use. And so again, we will simplify the choice between reactive, non-reactive, and we think that will be pretty cool. Also, potentially durable workflow orchestration, potentially Kotlin DSL as well, in order to replace builders, etc. But for now, we prefer to focus on other features. And last feature I would like to show, faster startup with IoT Cache from Project Leiden. So if you are building a Spring Boot application, you can potentially use build packs to basically create easily a container image. There is a new feature that is basically leveraging Java 25+. And by enabling a flag, you will automatically create an IoT cache that will be shipped within your container image, and that will basically make the startup of your application faster, requiring smaller CPUs and less memory for startup. So basically, if you enable this flag that I showed previously, you will just do boot build image, and basically the resulting container will be optimized and will allow to start at least twice faster. Be aware that next year, IoT code compilation should be released by the Java platform team. And so next year, instead of having a 2x boost, you will have a 5x boost, and really significantly lower the requirement in terms of CPU, etc. So it's just the beginning of the story. And this kind of feature that currently just allows 2x boost, it will basically start much faster. It will be able to reduce the warm-up time. So in addition to basically making the startup faster, if you are basically training your IoT cache on basically production workloads, it will be able to basically almost remove any warm-up. So basically, in a few seconds, you will have peak performance immediately, also lowering the need for more powerful CPUs because you don't have to run the JIT, etc. So it's pretty cool to see that with regular Java, the Java platform team is working pretty seriously on that, and that benefits to the Java developers and the Kotlin developers. You can, of course, use that without build packs, but then you need to basically deal manually with creating your IoT cache, shipping that in your containers, or deploying it. So it's totally possible. And Spring Framework 7 support for IoT cache will work perfectly well. It's just that it will require a bit more integration work on deployment, etc. So, but I think IoT cache is pretty nice to explore if you want to, if you are interested in efficiency for your Spring Boot workloads. Okay, I think I'm done. I'm available to answer to a few questions. Thanks. If you have any question, yeah, go to the mic, please.
Yeah, I was just wondering if you could comment on the future of WebFlux. Does WebFlux still have like a long-term future in the ecosystem now that we have virtual threads and other technologies for?
Yeah. So WebFlux remain well supported, and you can basically use it with virtual thread. We are going to improve, the interoperability between Spring MVC and virtual thread. We are going also to work on refining that. For example, with Netty, we have ways to optimize the workload on WebFlux plus virtual threads. So yeah, that's also an area, etc. Yeah, where we will.
Thank you.
First of all, thank you for your talk. I know that in the past there have been other libraries for nullability annotations like the checker framework or the JetBrains
Could you
annotation.
speak closer to the mic?
Sorry. There have in the past been other annotation libraries such as the checker framework or JetBrains annotations. I'd like to know, should I migrate those in my libraries to JSpecify annotations, and what will I do about some of these other annotations like the contract annotations from JetBrains? Will there be replacements for that in JSpecify?
Yeah, good question. So yes, I think you should migrate to JSpecify. JSpecify allows to provide annotations that are independent of the tooling and work in a pretty standardized fashion for your IDE. Your checker framework typically has likely support for JSpecify annotation. It only supports a subset of those features, but a very strong subset. You need additional annotations, like for example on Spring side, we are providing a contract annotation. JetBrains are providing the same. There is ongoing work to standardize that. We are working actively on that, so maybe later JSpecify will also provide some contract style annotation, but the discussions are a bit more complex than I was expected, so it takes a bit more time. So, but the goal is really to go toward that direction. But right now, use JSpecify for the core nullability constraints, and basically complete that with additional add contract annotation for the remaining semantics. And usually the tooling like Null-away supporting both contract and JSpecify, I think checker, it should be the same. So yeah, I would advise to do that.
All right, thank you.
Okay, thanks.